So hello friends, in today's video we will see how to derive the formula when a ray of light is refracted through a spherical surface. So the thing to keep in mind in this derivation is it's through a spherical surface and not a spherical mirror. So when we will make the diagram, we will not silver the either surface of the spherical glass. Okay, so now let's start with the derivation. So first of all, in any derivations, if in of ray optics, if you draw the diagram, the job becomes easier. So we will start with that only. So yes, first of all, you make a principal axis like this, a spherical surface. Okay, and suppose here is an object O. So from here the ray will pass like this. Now as soon as any incident ray touches the surface, will make normal on that surface. Okay, and we know that in any case of spherical mirror, the normal passes through the radius of curvature. Yes, ignore this disturbed line. Normal is always straight, but yes, like this. And now as there is a change in medium, this is medium 1, that is this is incident medium, and this is refracted medium. Okay, that is this is of n1 refractive index and this is of n2 refractive index. Okay, now this is the denser medium, this is the denser medium, and this is the rarer medium. So now as the ray goes from rarer to denser, it will turn towards the normal and it will start following this path. Now this is angle of incidence, this is angle of refraction. Okay, now let's say this angle is alpha, this angle beta, and this angle gamma. Now as this is a curved surface, we can calculate it easily, so we will just like make a straight line touching it. Okay, this is P, that is pole. Okay, this is normal, so I will give it a name N. Okay, I'll give it a name N, and as here image is formed, I'll give it the name I, this point. Now let's start with the derivation. First of all, we need to take the triangle. Which triangle? Triangle ONC. Okay, so let's take it. We have normal over here, N, and here is P, here O, and here it's C. Okay, this angle is alpha, this angle is beta, and if we properly draw it, this is angle of incidence. Okay, now as we studied in mathematics that if a triangle is like this, okay, the exterior angle is the sum of opposite interior angles. So ये angle होगा अल्फा प्लस बीटा. ओके, ये हमने प्रीवियस क्लासेस में पढ़ा है. सो फ्रॉम दैट रिलेशन यहाँ पे भी हम लगा सकते हैं कि I इज इक्वल टू अल्फ़ा प्लस बीटा. नाउ व्हाट इज़ अल्फ़ा प्लस बीटा? अगर हम इस अल्फ़ा का टेन थीटा निकालें, ओके, टेन अल्फ़ा इक्वल्स टू एन पी बाई ओ पी, एन पी बाई ओ पी, एंड अगर हम टेन बीटा निकालें तो दैट इज़ NP by PC or CP. So it will be NP by CP. Correct? After that, now we know that if theta is small, we can write it as alpha only, or sine alpha, or only alpha. So we will indicate this as alpha and this as beta, as theta is small. Okay, so that's it. नाउ ये हो गया एक चीज़. अब आपको लेना है सेकेंड ट्रायंगल, जो कि आप लोगे NPI, ट्रायंगल NPI. So it's like this. NPI, beta, angle of refraction, and gamma. So here also we can see that formation, that in exterior angle will be equal to sum of opposite two interior angles. So here also we'll make a relation that B equals, that is beta equals to R plus gamma. Here R means refracted angle. Clear? Now we can rewrite it as that is beta minus gamma equals to R. Okay, now what's beta here? Beta means NP upon CP, okay, plus, sorry, minus, what is gamma? Gamma is NP upon IP, correct? Equals to R, equals to this. Okay, here I forgot one step, that is I is now equal to NP upon OP plus NP upon CP. That's the equation 1 and not this. Here this is equation number 2. Now we will apply Snell's law by applying Snell's law at point N. Okay, what is the Snell's law? N1 sine I equals to N2 sine I. Okay, N1 sine I equals to N2 sine R, sorry. Okay, now what is N1 over here? We'll write it as N1 only. And what is sine I? What is sine I? As I told you, if theta is small, I'll just write the condition over here. If theta is small, then tan theta is almost equal to sine theta is almost equal to theta. This is an important condition. So on that basis, tan theta will also be equal to sine theta. Am I correct? Yes. So what we'll just do is we can directly write I over here. Okay, sine I. So and here directly sine R, not R, just R. Okay, now from these two equations we know what is I and what is R. Why we did this? Because theta is very small. So now N1, and what is the value of I? That is NP by OP plus NP by Cp equals to N2. What is the value of R? NP by Cp minus NP by Ip. Now we'll see if something comes out in common. So as we can see, NP all in all the four ratios, so we'll take it out as common. N1 NP by 1 upon OP plus 1 upon Cp equals to N2 NP, again common, 1 by Cp minus 1 by Ip. Okay, we'll cut NP by NP. Okay, and after that we'll put the values of OP and Cp. So from above we can see OP. OP is what? OP is the object distance over here. Object distance OP. So we'll write U, and object distance is always in negative. So we'll write 1 upon minus U plus, what is Cp over here? Cp. Okay, sorry. Before putting the equations, we'll just equate them, because we can see Cp common, so हमें उसे equate करना पड़ेगा. So we will multiply n1 and n2 with these two terms. So by doing that we can get n1 by OP plus n1 by Cp equals to n2 by Cp minus n2 by Ip. Okay, so now we can see over here that sorry, I did something wrong. No, I didn't. So from here we'll rewrite it as Cp को हमें एक जगह लाना है. So n1 by OP plus n2 by Ip equals to n2 by Cp minus n1 by Cp, if you agree. Yes, now we'll see it on next page. Yes, so we were here. Now we can make it as one like one operation, not operation, one term, that is n2 minus n1 by Cp. Yes, agreed. Now we will put the values. We know OP is object distance. We'll see what is IP. N2 by, we'll see the diagram, and we have IP, right? So what is IP? It's the image distance. So image distance is positive over here, and n2 minus n1 upon Cp. So what is Cp again? So Cp is nothing but the distance between the pole and C, that is the C means radius of curvature. So PC equals to R. Okay. Now the minus over here does not look appropriate, like it does not look good. So we'll just shift it over this side. So N2 by V minus N1 by U equals to N2 minus N1 by R, and that's our final formula. If you do not shift this also, no one can give you wrong, but just for the sake of soothing our eyes, we did this. So yes, that was the derivation for this formula. This formula is used when any ray is refracted through a spherical surface. Refraction through a spherical surface. And this derivation is very important, because after you learn this derivation, the lens makers formulas derivation will be very easy for you, because it just requires this concept only. So yes, thanks for watching. Please like, share, subscribe and comment if you understand this derivation. Thank you for watching.